Today I want to talk about circular motion and what does that mean and how do we use that. And this is actually used quite a bit in science, and it answers a lot of questions that we may have, and we'll get to those questions at another time. But today let's just talk about what circular motion is. Obviously it's moving in a circular path. So the first thing that we need to do is define what that circular path is. An object rotates around an axis. We have two of those. We have what we call an internal axis and an external axis. And the internal axis is when an object rotates around itself. So we have an object that rotates around itself. This is what happens if let's say we take a coin or we take a ball and we spin it. It's going to rotate around itself. So if I take an axis and I draw it through here, it is rotating around that axis. We call this rotation. Rotation is what we use to say when something has an internal axis. The other type of axis is an external. So obviously this is when an object rotates around something else. So an object rotates around an external source. So I'm just going to say rotates around something else other than itself. So this would be like if I take this object here and it's rotating this way. It goes around this circle, and so if the axis were right in the very center here, it would be going around that object. That is called revolution. If we rotate around an external source, it's called revolution. So let's use an example of the Earth, because the Earth does both rotation and revolution. How does it rotate? It rotates once every 24 hours. So as this thing spins on its axis, if this were the Earth, it would take 24 hours to go around one time. That is rotation. It revolves once every 365 days. It takes 365 days for the Earth to go all the way around the Sun. So let's say if this were the Sun, it would take 365 days for the Earth to revolve around the Sun. And of course this is where we get our day, and this is where we get our year. So that's what it means for an object to rotate or revolve around an axis. So how do we calculate that? What's our means of calculating this? Well, the first one is it's going to be a linear speed, and that is distance per unit of time. This is still going to be, as we have done all year, meters per second. It varies with the distance from the axis, and it is also called tangent speed. We need to know that because these linear speed and tangent speed are used interchangeably. So what does that mean? Well, if I go here and if I put an object here and then I rotate it. So let's take this. Let me group these two things together. If this were to rotate, how does that rotate? Well, the red dot is rotating around the circumference of that circle. That would be its linear speed. If I were to add a second red dot closer to the center of that circle, which one travels at the greater speed, or do they both travel the same amount? Well, if I take this and rotate it, the outside dot has to rotate faster to get back to the inside, or to get back to the same at the same time that the inside dot does, because the inside dot is on a shorter circle. Well, let's make my circle a little bit bigger here. There we go. Because this circle is smaller in circumference than this one, this dot has a greater linear speed than this one. And that's why we say, when we put this together, that's why we say it matters as to where it is. Because the outside dot has to travel a greater distance to get back to the same point at the same time than this one. So the closer you get to here, the less tangent speed it has. The further away you get, the greater the tangent speed. Now another thing that we need to consider on this is that it is tangent speed. If this object is spinning in a circle, and I were to cut the rope right here, what path would this object take? Well, we know that it's tangent, so it's going to take this path as it goes. And this is going to happen all the way around. When the dot's here, it's tangent. It is tangent to the circle. It connects to this at this point. So it's tangent to the circle at this point. So this is what we call our tangent velocity. How do we calculate this? Our formula is tangent velocity is equal to 2 pi times the radius, which is our circumference, divided by the time period. Well, let's look at what time period is. Our time period is the length of time it takes for an object to go around once. So if we take an object, so let's go ahead and put that down. Time it takes to go around one time. Anyway, sorry, I had a phone call. Time it takes to rotate one time. Once. So our formula is time period is equal to 1 over frequency. So what is frequency? Well, frequency is how many times does it go around. So how many times does it go around in 1 second? That's our frequency. And our formula for frequency is the inverse of the 1 for time. So it's 1 over the time period. So let's say we have an object that rotates 30 times. So let's put 30 times. And let's say it takes 10 seconds for that to rotate around 30 times. So by formula, I'm just going to take it. I'm going to get rid of this. I don't know why it's there. So by formula, I'm going to take it and say my time period is 10 divided by the 30. So obviously that's going to be 0.33 seconds for my time period. So that calculate that. To calculate then what is my frequency? My frequency would be 1 divided by the 0.33. So how many times does it go around in that period of time? So 1 divided by 0.33, and that is 3.03 times. So it goes around just a little bit more than 3. And by the way, our unit is a hertz. So that's our unit for frequency, hertz, and we abbreviate it Hz. So let's go back up to here. So now we've got our time period and we've got our circumference. This is distance divided by time. So we can calculate, if we have the circumference, we have the radius of the circle, take the radius and divide it by, or 2 pi r divided by the time period, we get the tangent velocity of this object. The other type of speed that we concern ourselves with is called rotational speed. It is also called angular speed. It is the number of rotations per unit of time. We know it as RPMs. That's how we use it in our world. RPMs. It's rounds per minute or rotations per minute. It does not vary with distance. If you take an object and if we put several different parts here on the circle, we take this and fill it in and get all these various points, and let's go ahead and group all these. So if we take that, if I turn it, they all turn and go around once at the same time. All points go back to the same place at the same time. They have different linear speeds because the circumference of the circle in which they're traveling is different, but they all have the exact same rotational speed, which is also called angular speed. So everything is going to rotate the same with rotational speed. We've calculated our tangent speed already. So let's go to centripetal acceleration. Centripetal acceleration. I'm going to have some questions about this in class. The first thing is, what does centripetal mean? Centripetal means center seeking. So in other words, if I have an object that is in a circular path, in what direction is the acceleration? It is towards the center. Always. At any point, the acceleration is toward the center. That's the direction of the acceleration. I'm going to talk a little bit more about this in class. The formula is our centripetal acceleration is equal to the velocity squared divided by the radius. And the radius makes sense because it's going along the radius. The velocity squared is, if we take this, we can do things with the tangent velocities, and we know that the velocity is constantly changing because it is acceleration. And the last thing that we need to talk about in this video is centripetal force. The force, same thing, it's centripetal, so it's center seeking. So if you take something, in what direction? The force is also going towards the center. That's what's causing it to travel in a circular path. Our formula for centripetal force is centripetal force. It's still mass times acceleration, like we did with Newton's second law, but now acceleration is velocity squared over the radius. So our formula for centripetal force is mass times velocity squared divided by the radius of the circle. In the next video, we're going to do some examples with these formulas.